Welcome to another class. And in this tutorial, we want to dive very deep in the concept of set theory. But if you are just coming to this channel, please do well to subscribe and turn on the notification bell just to be aware of when I drop a new video. And let's start with the definition of the set theory. So the word set itself is a collection of a things, but it might not be only a things. So it might be the collection of an object and others like that. So just like if you are just combining different things in a place, so we call it a set. And that thing you are collecting will have a name given to what was enclosed in it. So suppose you have the set of mathematical sets, all right? So let's say we have a mathematical set. So and this example is very common, let's say, it's very known to us. We have a mathematical set. Suppose I denote it with A. So and what are the things we can get in mathematical set? So we have pencils, we have pen, we have erasers and others like that. So we still have like compass, protractor, rulers, and others. So all these things they are set, but you cannot be mentioning pencil, ruler, and all other items separately. We need to denote it with something. So that's why we call it mathematical set. And let's see the set of alphabet. So and if I denote it with phi, and what are the alphabets? We have A, B, C, D, and others like that. So these are the set of alphabet, but we cannot be mentioning ABC only, so we can just give it a name, alphabet. All right. And the next thing is if you have the set of country, in the country we have different states, like let's say Kwara State, we have Kwara State, we have like Lagos State, Kaduna, Kano, Katsina, all those things. They are the states under the countries. All right. So and I will still explain more on the example given the above, but let's see the second aspect of this, which is the set notation. So note that uh, in this set notation we must know three important things, and the first thing is a set is always denoted by capital letter, while the elements are denoted by small letter, and we always use the curly braces. All right. And let's now back to the example given above. So you know that I denote the set itself as capital letter, while the elements in it with the small letters, and all of them they are enclosed in a curly braces. If these all the three characteristics complete, so which means our set is also complete. Another example is if you have the set of B equals to, if I give like let's say 1 2 3 4 dot dot dot, all these are also a set where 1 2 3 are the elements, all right, and which are in a small case, while this B is a set itself which is in uppercase, while we have the curly braces. So that is all the elements we always enclosed in a curly braces, and that is what defined a set. And we must know that we cannot use any other bracket except curly braces. If you use this open bracket or use this close bracket, they are totally wrong. All right, so we only use curly braces in a set. And if you want to use this open bracket, this close bracket, so just put zero very close to the lines, and so that is still allowed. All right, but the perfect one is the one I just draw now. So that is the introduction to set. Now what are the forms of a set? So there are two different forms of a set. So the first one is roster or list, while the second one is set builder. What are the rosters? Okay, the roster is just like you list the elements. So the we are given a question, so and the all the element of that set has been given. So that is automatically roster. So you have rostered the set or you have listed the set. Suppose you have y equals to a comma b comma c comma d comma e. All these one they have already been listed. If you have set G equals to 1 2 3 4 and 5. So all this one they are also roasted already. So I'm giving the two examples in alphabet and in number. So what of set builder? So the set builder is just like from what the name implies, you are going to build the set. And how are you going to do that? If you are given a set let's say we are given a set A equals to x such that if you have x greater than or equals to 2. So I used greater than or equals to 2 here. So the word greater than or equals to is an inequality symbol, and mostly the set builder always come in form of inequality symbols. You know that I didn't define this x on anything. I'm going to define it on something later. Let's say we are giving set B equals to if we are giving let's say numbers. And what are those numbers? So let's say the numbers in a natural we have a number in a natural one that is less than 10. A number in natural numbers less than 10. Okay, so this one is also a set builder. It is in a statement form, but you are going to build out the set. And what are the elements of the set? So the word less than and the word natural number is this. Now, the natural number starts from 1 to all the positive infinity, all those bigger number. But since you are given a restriction, we need to stop at 10, at 9, because the number less than 10. So let's say I define this one, I mean the first one, I define it on a natural number again. As you know, the natural number is 1 upward, all right? So let's say x here is a member of natural number, and that symbol n is a symbol of natural number. And since it is greater than or equals to 2, that is, we are going to start from 2, then to as many as given number that we have. But suppose there is no less than, there is no equals to there, that is, we are going to start with 3, then to upward. But because of this less than, it makes us start from 2. Now this x itself can still be 3, can still be 2, or x can be 3, 4, 5, and up. That is the essence of that equal. That is the essence of that equal. And so for the second example, if I use less than or equals to, it means that we are stopping at 10. But if I use less than, we stop at 9. So that is for the first part. And welcome to another part. So where we are going to be discussing the numbers used in set builder. And what are those? So if you see this set, this set is called integer. We call it integer, but integer is of uh, 3 parts. So we have positive integer, negative integer, and zero as an integer. So if we are given the set of integer, let's say I just combine everything since it is not stated. So we are going to have dot 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 negative. We have 0, and we still have positive integers dot dot dot. The word dot 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 means the number continues to the left hand side and to the right hand side with negative and with the positive. And what are the negative here? Let's say we have dot dot dot, and here is -2, we have -1, we have 0, and while for the positive side we have 1, 2, dot dot dot. All these one, they are integer, so without separating them. But if you start separating them, we have the negative integers, we have the positive integers. All this side, they are positive, and wow, this other side here, they are going to be negative integers. All right, so why the middle one, which is 0? So just like a number line, so we have 0 at the middle, we have positive to the right and negative to the left. So why the natural numbers is given as this n, and they are the number that starts from 1. Any number that starts from 1 to positive infinity, as I've explained earlier, we call them natural number. As it implies, they are natural. They are naturals. So, and those are the values. And let's see the types of a set. So, as we all know the introduction already, which we also explained some concepts. So, let's see the types of a set. Types is different from form. Here are the types of sets. So, the first one is finite set. So, it's a roster set with an ending numbers of elements. So if you are given a set of if you are given a set, so when the element in it is defined, as it has an ending, so we call it finite number of a set. So it can be in a roster form, and sometimes it can also be in a set builder, but set builder with a condition that the thing must have an ending. It must have an ending. Like this example I just gave now, 1, 2, 3, 4 is a final set because you know all the elements in it. And let's say we still define other elements. Let's say odd numbers less than 10. Odd numbers less than 10. What are the odd numbers? So the number that cannot divide with any number except a number that can be divided by any other number, 1 and itself. All right. And what are those numbers? remember the odd number 2 cannot divide odd number. Okay, so we only have odd number as 1, we have 3, we have 5, we have 7, we have 9, 11, 13, 15. So I'm using 15 because 3 can go in 15, 5 can go in 15. I use 9 because 3 can go in 9, 9 can go in 9, 1 can also go in 9. So these are the element of odd number, but with this condition it is less than 10. That is, we are going to stop at 9. If that is clear, so let's see the second one, which is infinite set. So it's just like the opposite to it. When the first one has ending, the second one will not have ending. And it's also mostly on set builder or otherwise. That is, can also be none. Okay, and let's say we have set C equals to all even numbers. Just imagine the word all even numbers. And we know even numbers are the number that are divided by 2. Okay, so if I say all even number, that is, the number doesn't have ending. That is 2, 4, 6, 8, dot, 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 dot. So you cannot see the last number of this. So that is infinite set. Okay, and let's see the cardinality of a set. So it is the total number of elements in a set. And note that total number of elements in a set, that is, we are going to sum all the numbers together, and if there is a repeating element or elements, it counts as one. That is, when you are counting that cardinality, or when you are counting the numbers, number must not repeat. And if it repeats, if let's say it repeats, you count it as one. And here are the examples: 1, 1, 3, 4, 5, 7, 7. So let's see how to go with this. So we denote cardinalities as number of D. N of D is mean number of D. So we have 1, 1 here. So that is 1, 3, 4, 5. Then we have 7, 7, which is 5. That is 7, 7 repeat, 1, 1 repeat. So we count them as 1, and the total number is 5. So while for the singleton, it is a set of single element, just single element. When we have just one element in a set, we call it singleton or single set. So the next one, which is number 5, is empty set. In this set, no entry. I mean, no entry in a set. So let's say you just give a set builder in a set. Just make sure that you check the conditions. Check the condition before you answer it. So similarly applicable to single set. You will be given a statement word, and make sure that you interpret the word very well before you answer the question. The question might result into singleton or into empty set. For instance, human being with a tail. I mean the higher human being. That is, those that can reasonable well, not like animals. So no human being has a tail. Okay, you are taking of Avanta, so I don't have business with them. So just know that human being with a tail is an example of empty set. We can use this curly braces or use this symbol, which is phi, or you can also put phi in a bracket. So now let's see the parallel set. So the parallel set, this is a pre-subset of a set, and it's a pre-subset of a set. So I'm going to explain subset later, but just know that it's a pre-subset. And what does it do? It spy on subset by letting us know the number of subsets in a set. So we'll be given a set and required to find a subset, but we want to disturb ourselves in counting all the number, or let's say in writing all the subset, we just use power set to know all the subset beforehand. So suppose we are given A equals to 1 to 3, and to know the power of set, so we are going to write, let's say we are given A, that is A of, since we are looking for the number, the formula is 2 raised to the power of n. Alright, so where n are the total number of elements in a set. Don't forget, when element repeat, count it as 1 according to cardinality set. So from this, we are given 1 to 3, which is 3. That is 2 raised to the power of 3 equals to 8. That is, there is going to be 8 subsets in a set of 1, 2, 3. 8 subsets. Alright, and I'm going to show you how we get all this in the next part. I hope you are enjoying this. And you are welcome to another part, which is the subset. Uh, a set of which all the elements are contained in another set is called subset. So just like sub, that is under. Okay. So under the set, that we are going to give a bigger set, then we are now going to be taking some sets from that set. As in, we'll be taking out some sets in a bigger set. That is what I mean by the word subset. And the symbol is this. So if you have this symbol just like C, we just elongate C and it faces the right hand side. So we call it subset symbol. And let's see the example of this subset. Remember, sub of a set. We are going to be given a bigger set and we'll be developing some small sets in it. All right. And let's say we are giving A equals to 1, 2, 3. So this 1, 2, 3 is a set itself. And how can we know the subset according to these definitions? So in this, I can take out 8 different subsets in this set. And here are the first one. So the first one is 1 because 1 is in this set, 2 is in this set, 3 is also in this set. So that is 1, 2, 3, they are the subset of this set. They are the subset of this set. And this one, they are smaller than the real set. 1 is smaller than it, 2 is smaller than it, 3 is smaller than it. So all this one, we call them subsets. But this is not the final subset for this. I just use this one to explain first and let's move further. So for the single. So let's see how to double this. I can still see 1, 2 in this. I can also see 1, 3 in this. And so after I've counted 1, 2, and 1, 3, so I can also see 2 and 3 in this. Okay. Yeah, so I can also see 2 and 3 in this problem. So then I can also see 1, 2, and 3 in this problem. So once all these things has been gotten, then the last part is going to be empty set. Note that empty set is a subset of all the sets. When finding the subset, so we consider empty set as a subset of all the sets. All right. And note that we are counting forward, we are not counting backward. So some might say, okay, what of 2 1, what of 3 1, what of wow. So what of this one supposed to be 3 2. So I'm going to correct it with a watermark. And so we are going to consider 1 3 is not 3 1 and 1 2 is not 2 1. So because 1 2 is forward counting and 1 3 is 3 1 is backward counting. 1 2 is forward, 2 1 is backward. 1 3 is forward, 3 1 is backward. So we are counting forwardly, not backwardly. And here are the subset of set. You know, if you count this, they are 8, and which has been explained in a power set. Okay. So and we can now conclude that. So if you have 1 here, 1 is a subset of 1, 2, 3. That's just simple as that. 2 is a subset of 1, 2, 3. And we consider 1 as a subset, and while we consider 1, 3 as a superset. And note that 1, 2, 3 is a subset of itself. Thank you for watching. I will see you in the next class. Stay tuned, stay connected. Bye bye.